సబ్స్క్రైబ్ చేయండి అండ్ ఫర్ మోర్ అప్డేట్స్ బెల్ ఐకాన్ క్లిక్ చేయడం మర్చిపోకండి.
Students, now we are going to discuss the wave motion and also different types of wave motions. Discuss the mainly the definition of the wave. Wave is the defined as some disturbance. This is the medium. Let us consider this is the water surface. In the water, some disturbance, that disturbance is propagating this type. So the disturbance in some surface, some medium. So these are all particles. Particles transfer to from one location to another location. So a rock or any thing through in water surface, then water particles propagating this type of propagating, then the particles are transferred one location to another location. This is the wave. So that is the wave. Motion of the wave means some displacement, travel to one location to another location, travel to one location to another location. So this is the wave motion. Mainly wave motion is two types. So waves are generally two types. That is the mechanical waves, electromagnetic waves. Waves are generally two types, mechanical waves and electromagnetic waves. And also wave motion is to be two types. There are two types. That two types are transverse wave and longitudinal waves. Waves are two types, generally transverse waves and longitudinal waves. And wave motion, transverse wave motion and longitudinal wave motion. The definitions of transverse waves and longitudinal waves. The nomenclature, long means, so the wave motion along to this type. This is the longitudinal waves. So the wave propagation this type. Okay, then what is the name of transverse? Transverse means perpendicular. This type. This motion is transverse motion. Okay, then what is the transverse waves? Transverse waves. Transverse wave creates disturbance. Transverse wave creates a disturbance perpendicular to the propagation of energy transfer. So so in the water surface, through the rock or brick or anything, then creates the some disturbance. This type of some disturbance, up and down, up down, up down, up down, up and downs. Some disturbances up and down. This direction is perpendicular to propagation of energy. Then energy transferred from this point to this point. So energy, the direction of the energy transfer is this direction. Then the oscillations are perpendicular to this direction. This type, up and down, up and down, up and down, this type. So the oscillations are perpendicular to the propagation of direction of propagation of energy transfer. So these are transverse waves. So transverse waves means a wave can be transverse where a disturbance creates oscillations that are perpendicular to the propagation of energy transfer. So this is the definition of the transverse motion. A wave can be transverse where a disturbance creates oscillations that are perpendicular to the propagation of energy transfer. The direction of the energy transfer is, this is the direction of the propagation of energy transfer. The waves are this type of motion. So this is the transverse wave. Next of all, longitudinal waves. Longitudinal waves means the energy transfer is the direction of this is the direction of propagation of energy transfer, and the oscillations are same directions. The oscillations same directions. So this is the direction of oscillations, and also this is the direction of propagation. So these type of waves is called as longitudinal waves. Then longitudinal waves definition. A wave can be longitudinal where a disturbance creates oscillations that are parallel to the direction of propagation of energy transfer. So this is the longitudinal wave. This is the longitudinal waves. So generally waves are two types, that is the transverse wave and longitudinal waves. So examples of longitudinal waves: so mechanical waves are both transverse waves and longitudinal waves. Mechanical waves are longitudinal waves and transverse waves. Mechanical waves are longitudinal and also transverse waves. But electromagnetic waves are transverse waves. Electromagnetic waves are transverse waves. Waves are transverse waves in free space. In free space. So some examples. This is the tuning fork. So the tuning fork hit the rubber hammer. So the waves are produces this type of so the tuning fork vibrate same this type of vibrations. So if the particles of the medium move up and down, up and in the water, up and down, and also left and right, about their equilibrium position. This is the equilibrium. This is the mean position. This is the equilibrium. So this is the equilibrium position. This is the equilibrium position. This is the mean position. This is the equilibrium position. If the particles of the medium move up and down about their equilibrium position perpendicular to the direction of propagation of the wave is called transverse waves. And also if the particles of the medium move left and right about their equilibrium position and perpendicular to the direction of propagation of the wave is called transverse waves. And also longitudinal wave means if the direction of the vibration of the particle, if the direction of the vibration of the particle is the same direction of the propagation of the energy transfer is called longitudinal waves. Okay. Another way, the waves are two types: progressive waves and stationary waves. Progressive waves and stationary waves. So the differences between progressive waves and stationary waves. Progressive waves are due to continuous periodic vibration of particle in medium. So the differences, discuss the differences. Progressive waves, stationary waves. So in progressive waves are due to continuous periodic vibration. Periodic vibration means so simple pendulum. This is the periodic vibration. This is the periodic vibration. Progressive waves are due to continuous periodic vibration of particle in medium. Progressive waves are due to continuous periodic vibrations of particles in a medium. But in stationary waves are due to the superposition of in stationary waves so progressive waves are produced due to continuous periodic vibration of particle in medium, periodic vibration. But stationary waves are produced superposition of two waves. Superposition means, so this is the move, this is the superposition. So the combination of two waves superposition overlapped. This is the wave, another wave overlapped. This is the wave, this is the overlapped. So the stationary waves are produced due to superposition of similar waves. Superposition of or overlapped. Superposition or overlapped. So the stationary waves are due to superposition of two similar waves. Similar waves means similar frequency waves are combined of similar frequency waves are is called stationary waves. So stationary waves are produced due to superposition of two similar waves moving in opposite direction. One wave moves with this in direction, another wave opposite. So these type of waves are produced in stretched strings. For example, this is the fixed then string. So this string moves this type of vibrations. Then both ends are fixed. The string, this type of vibrating. So these are all stationary waves. So same frequencies, but superposition in the two fixed ends. So stationary waves are due to the superposition of two similar waves moving in opposite directions. So progressive waves are due to continuous periodic vibration, and stationary waves are due to the superposition of two similar waves moving in opposite directions. So in the superposition in the progressive waves and stationary waves, second point is the all particles simple harmonic motion with same amplitudes. So in the progressive waves, all particles executes simple harmonic motion with same amplitudes. But in stationary waves, different particles executes SHM, simple harmonic motion, with different amplitudes because a string fixed at two ends. This is the two fixed ends. This is the string moves this type of move, another opposite direction, this. So in the opposite direction and superposition. So here different types of amplitudes. Here amplitude is the minimum, here amplitude is the minimum, this is the position. Here amplitude is the minimum, here amplitude is maximum, here amplitude is the minimum, here amplitude is the maximum. So different amplitudes, different particles executes SHM with different amplitudes. So in the minimum amplitude is nodes, maximum amplitudes antinodes. Minimum amplitudes nodes, maximum amplitudes antinodes. Any two antinodes or any two nodes, the distance between any two nodes and also any two antinodes is lambda by 2, of wavelength. Third point, energy flows across every plane in the direction of propagation of waves. So energy flows across every plane in the direction of propagation of the waves. In stationary waves, there is no flow of energy across any phase. There is no flow of energy across any phase. Okay. Next point, at a given instant, different particles of the medium will have different phases. Here at a given instant, different particles of the medium will have different phases. All particles between the nodes vibrate in the same phase. Here all particles between the nodes vibrate in the same phase, Okay. Next point, in the progressive waves, all particles do not pass through their mean position. It means all particles do not pass through mean position. All particles do not pass through their mean position. In stationary waves, all particles pass through their mean positions. Here do not pass through. In stationary waves, all particles pass through their mean positions. Okay. In the progressive waves, no particles no particles on the wave is permanently rest. In stationary waves, nodes are permanently at rest because this is the node. Nodes are permanently rest in the minimum amplitude. Here in progressive waves, no particles on the wave is permanently rest. Okay, these are differences between progressive waves and stationary waves.